Hello everybody, I'm just going to be going through the level 9 screening test, number screening test. I'm just going through the questions here. Please leave comments if you've got any questions about them. So it's 40 questions, so here we go. Question 1, meter on our family car reads 18,399. What will it read after the car has gone 1 more kilometre? 399 plus 1 will be 400, so 18,400. Put a little comma there. Don't really need a comma for an odometer. I guess it's just habit for me, sometimes with thousands. Number 2, write the next 3 numbers in this descending number pattern. 1743, 1733, 1723 is clearly going down by tens. So we can see the tens value is going down. 4, 3, 2. So it will go down to 1 and then to 0. And just like if we have 100 and we take 10 away, we go down to 90. Now we've got 1700s. So when we go one less than 1700s, we go 1600s. And like I said, when we go from 100 down by 10, you go down to 90. When you go from 1700s, you go down to 1690. And obviously we keep the 3 because we're just taking 10 every time. It's the same if it goes the other way, adding 10, adding 10, adding 10, and so forth. Question 3. Write the next 3 numbers in this ascending number pattern. From 0.2 to 0.5 is gone up by 0.3. It's gone up another 0.3 from 0.5 to 0.8. So we need to add another 0.3. And we're talking about tenths here. How many tenths are there in a whole? There's 10 of them. But if we add another 3 to this 8 tenths, we're going to have 11. And 11 tenths looks like this. 1 and 1/10. And then if we add another 3 tenths, it's going to be 1 and 4/10. And another 3, it's going to be 1 and 7/10. So just remember, we're using base 10 system with our numbers, which means as soon as we get past 9 and we go to 10, things have got to look a little bit different. We're going to go from 0.8, 0.9. It doesn't say 0.10 because 0.10 is actually 0.1, which is smaller than 0.2. So we have to increase according to place value. What was a 0 in these first ones, once there's too many in the tenths, we need to add to the units, and hence why we've got a 1 at the front there. Okay, Olga is 100 years old today. In what year was she born? The day and the month and things like this aren't that important, but what is important is the year. We're currently in the year 2021. If she's 100, that means she was born 100 years earlier, so we have to take 100 from that. 1 take 0 is 1, 2 take 0 is 2. 0 take 1 can't be done, so we've got to take from this one to make a 1, and then that means that you put a 1 there. So it's 10 take 1 is 9, 1, 19, 21. And it makes sense. 2021, 1921. Both the times ending in 21. Estimate the number shown at the arrow. Well, my finger's fat enough to do it. So maybe there's 1, 2, 3, 4, 5, 6. Oh, 6 and a bit. So it's a little bit, there's a little bit more space than 6 fingers worth, which means that it's not quite as big as a 6th. It's a little bit bigger than that. I'm going to guess about, so it's a bit bigger than a 6th. A 6th, you know, if you do 1 divided by 6 in a calculator, that tells you what a 6th is, and that's 0.16 recurring. But actually, we're using the number 10,000, so a 6th of 10,000 will be 1,600. We can just do 10,000 multiplied by a 6th to get that. But yeah, I would say it's probably closer to maybe 2,000. It's about a fifth. So there's a 2,000, a 4,000, a 6,000, an 8,000, about that. So I'd say it's about a fifth. So 10,000 divided by 5, 2,000. So I'll give 2,000 as my answer. So you've just got to think about it as if this is a ruler. If this is at a 0 and this is at 100, what would this number be? You know, and my guess is that it's saying it's 20. They're just adding a couple more zeros to make it look a little bit trickier. Right, $3.05 using decimal notation. So this is what $3 looks like. This is what 5 cents looks like. So we just have to add the two together and you'll get $3.05. Circle the decimal which best represents the amount of the box shaded. So I'll just do very rough estimates. So I'm just replicating, so I'm just doing a copy of how wide it is. So 1, 2, 3, 4, 5, 6. So let's say it's about a sixth. A sixth is at 0.16. And obviously 0.15 is really close to that. So my guess is A, 0.15. Question 8. For each of these decimals, circle whether it is closer to A, B, or C. So nearest to 0, nearest to 1/2, nearest to 1. 0.1, that means it's only 1/10. So because that's what that number there is. If there's 10 tenths available to make a whole and you've only got one of them, that means you're very close to 0. Keeping in mind that 1/2 is 5 tenths because it's equivalent fractions. 1/2 equals 5 tenths. But we only had 1/10. 0, of course, is 0 tenths. 5 tenths, 10 tenths. So we only had 1, so that's very close to 0. 0.08, that is 8 hundredths. That is very, very small. So half is 50 hundredths, whilst 1 is obviously 100 hundredths, but we've only got 8 hundredths, so again, it's very close to 0. 0.9, we're talking about 9 tenths now. So that's almost, the whole cake, 90% of the cake. So that means that we're going to be closest to 1. So again, half is going to be 5 tenths, as we've written up there. 0 tenths, 10 tenths. 9 tenths is very close to 10 tenths. Circle the larger decimal in each pair. 2, 2, they're the same. So we've got to go to the next place value. 0 compared to 3, 3 is bigger. 4 and 4, the same. 7 and 5, 7 is bigger. Circle the larger decimal in each pair. 3 compared to 3, the same. 4 compared to the 3, 4 is bigger. 5 compared to 5, the same. 1 compared to 1, the same. 7 compared to 7, the same. 5 compared to what would be over here? 0. We can have 100 zeros afterwards. It doesn't change anything when it's after the decimal place. Always remember that. Zeros after the decimal places, after your last number, it doesn't change anything. 5 is greater than 0. So 5.175 is the larger one. Number 11. Draw a circle around 1/3 of the cans. 1, 2, 3, 4, 5, 6. There's 6 cans. And what 1/3 means, it means 1 out of every 3. 1, 2, 3. So we can circle this one. I'll put a tick in it. 1, 2, 3. So I'm circling 1 out of every 3 cans. 1 out of every 3 in terms of 6 is 2. Okay, let's keep going. Shading 3/4 of this shape. 3/4 means if you cut it into 4, an easy way to cut into 4 is to first cut into 2, and then you can just half those. So I can either do it crossways or vertical. I'm going to go vertical this time. And if you color in 3 out of the 4, 1, 2, 3, obviously you can color more than that. But as we can see, I've cut it into 4. So it's out of 4 pieces, and I've colored in 3. There's my 3/4. Circle the fraction which represents the largest amount. 5/6, 5/7, 5/8, or 5/9. Now, that bottom number is how many equally sized pieces there are of your shape. So as a very basic example, if we've got 2 identical circles and I cut one of them into 2 pieces and one of them into 4 equally sized pieces, you can see that the 2 is bigger than the 4, because it's a bit like if you have a pizza and you split it between 2 people, or you split it between 4 people evenly. If you split it between only 2, they have more to eat. Their pieces are a lot bigger than what these little ones are. So it's exactly the same principle. 1 out of 2 is much bigger than 1 out of 4. Much bigger. So the smaller number here will actually result in getting your answer, not the bigger number. So a more extreme example also would be something like, let's say, if you compare 5 out of 10 compared to 5 out of 100. If you had to cut a cake into 100 pieces, it's going to be very small pieces. 5 out of 100, it's still 5 pieces, but there's 5 very small pieces. If it's 5 pieces out of 6, like we have over here, which is actually our answer, that's got the smallest denominator out of all of them, 5 out of 6 would look something like this. I'll just draw it on the side there. So here's our cake. Split it into 3s, and then if you split each of those thirds into 2, and you've got 6. And if I shade 5 of those, 1, 2, 3, 4, 5. So that's 5 shaded out of 6. That's the largest amount. Question 14. Mark and label the numbers 1/10 and 4/5 in their current positions on this. So what we should do, if you don't know what these are in decimals, it makes it a little bit harder. I know what they are in decimals is 0.1, because that's 10 divided by 1 gets 0.1. Sorry, 1 divided by 10 will get you 0.1. 4 divided by 5 is 0.8, because a fifth is 0.2, and we've got 4 of them. 4 times 0.2 equals 0.8. But let's try to do it like this. If this is 0 and that's 1, well, half is about here, and that's going to be 0.5. Now, we want a tenth, so that would be like if there was 10 lines here, evenly spaced. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So based on that, each of these little dashes, just like your ruler, is representing increments, or little numbers that are a tenth each. So this is 1/10 down there, and this next one would be 2 and 3 and 4 and so forth. Now 1/10 is one of the things that we're looking for, so that's one of our answers down here. And the other one was 4/5. Now it would be good if these were both in the same terms, like same denominator. So what do we do to 4 out of 5 to make it out of 10? Just times them by 2. 4 out of 5 times 2 equals 4 times 2 equals 8. 5 times 2 equals 10. So it's 8/10. 1, 2, 3, 4, 5, 6, 7, 8. There's my 4/5. You don't need to have those boxes around it. I was just trying to highlight that amongst all my other scribble. There's our first couple of pages done. Now, you are going to walk once around a square-shaped field. You start at the corner marked S and move in the direction shown by the arrow. Mark with an X where you will be after 1/3 of your walk. Now, there's obviously 4 sides, and we're going to be going 1/3. Now, if there was 3 sides, and we're going to be going 1/3, it would be easy. You just go one of those sides. But because we've got 4 sides, it's got to be 1 and a bit more. So we have to have gone 1 complete side. And how much more do we go down this side? Well, it's actually 1/3 of the way, because if you have 3 lots of 1, and then that will give you 3 when you add them all together. And if you have 3 lots of 1/3, that will also give you 1 when you add them all up. Just think of it like this. You've got a pizza, split it up into 3s. That is 1/3. So are all the others. 1/3, 2/3, 3/3. That's 1 whole pizza. That's 1 whole. 1 plus our other 3 ones will get you 4. And that's what we needed to get. We need to get 1/3 of 4. So it would go 1, and then it would go 1/3 of the way down, which I'm going to say is about there. X marks the spot. Over here will be 2/3, and over here is obviously 3/3 of the whole way down the side. Bit of a trickier question, that one. Number 16. Dale had $150. She spent 100% of it. If she spent 100% of her money, then she has 0% left. 0% is $0. 17. I made a jug of juice, 50% orange juice, 50% water. I poured half of it into my glass. What percentage of drink in my glass is water? Well, if it was half juice, half orange, half water, and it's been mixed up, so it's all nice and even, and you pour it into your glass, then it's going to be the same. It's still going to be 50 of each. So it's going to be half orange juice, half water. It's asking how much is water? Half, 50%. Pouring it from one glass to another doesn't change the mixture. It was a 50-50 split in the jug, the big container. It will be a 50-50 split in the glass. Okay, question 18. Jim bought 3 sleeping bags at $98 each. How could he work out how much he spent? So 98 is $2 less than 100, and his 3 sleeping bags, so it's 3 lots of 100 minus 2. So you need to minus 3 lots of 2 from your 3 lots of 100. So you have all of the options say 3 times 100, that's good, but you need to have minused $2 3 different times. 3 times 2 is 6. So you need to do 3 times 100 minus 6. Another way that could have helped you know whether you're on the right track, this is maybe a little bit trickier, but this is where times tables always helps. If you're buying something that ends in an $8, you're buying 3 of them, 3 times 8 equals 24. That last digit there is a 4, which means your answer has to end in 4. 300 takes 6. 299, 298, 297, 296, 295, 294. That ends in a 4, which means it could be correct. This would be 297, which is no good. 298, no good. 299, no good. 294 was what we wanted. We can get that by making sure we are minusing 3 lots of 2. $2 from each sleeping bag amount, or from the $100. Okay, question 19. John did a calculation, so he did a sum, and the answer was 5 remainder 3. What might the calculation be? So there can be lots of different answers for this, but I just thought of a times table, which is something multiplied by 5 with added with 3 added on top. So I'll give a few examples. If you did something like, let's say 2 times 5 equals 10, and then if you add 3 to that, 10 plus 3 equals 13. That number there, from the multiplication by 5, which is the opposite of being divided by 5, and adding of 3, instead of having a remainder of 3, see how they're opposite? This means that if you did, actually that's a terrible example, I'll give a much better one. If you did 5 times 5 equals 25, and if you did that 25 plus 3 equals 28, now with that 28 divided by 5, you will get 28 divided by 5 is 5 with 3 remainders, 26, 27, 28. So there are a number of other ways that you could do it. You just need to have multiplied a number by 5 which is greater than 3. That's where my first mistake was. Because if it's 3 or less, then it's not going to work. So again, I'll try with one other number. I'll try, let's say, with 7. 7 times 5 equals 35. If we add 3 to that, 35 plus 3 equals 38. That can also be used to get our answer. 38 divided by 7. How many 7s fit into 38? I'll put it on the side here. 7, 14, 21, 28, 35, 42. Oh, that's going to be more than 38, so we can get rid of that one. 1, 2, 3, 4, 5. 5 7s, and then how many remainders to get to 38? 36, 37, 38. 1, 2, 3. 5 lots of 7, 3 remainders, which is what we're trying to get. We're trying to get a sum that will give us that answer, 5 remainder 3. Question 20. Elizabeth is putting 6 pencils in a row. The length of the row is 100 centimeters. So I'll just draw that. Here's one pencil, here's another pencil, 3, 4, 5, 6. And those pencils end up being 100 centimeters. Now it's saying how long would it be if it was 9 pencils? 1, 2, 3. Now, if 6 of something equals 100 centimeters, how much will 9 be? Well, we should be able to know that 9 is a whole 6 plus half of the 6. So while 6 is 100 centimeters, 1 meter, 9 should be 150 centimeters because it is 1.5 times as much. If you get 1 of 6 and then add half of 6 to it, to the existing 6, you will get 9. Another way of looking at it would be something that's 100 centimeters and there's 6 of them. That means that you could do 100 divided by 6. You can put that into your calculator, 100 divided by 6, and that will tell you how much each one is. And it's going to tell you about 16. But now that means that each pencil is 16 centimeters across, but we've got 9 of them. So what we would need to do would be, we'd need to get that 16 number, get the exact number from your calculator, multiply that by 9, and it's going to get you 150. That's all we needed to do. Figure out what one of them is, multiply it by how many it's asking for. It's asking for 9. That's why we're multiplying by 9. It's definitely one of the harder questions though on this test. Use a pencil and paper to help you with these sums, show all you're working. So 158 plus 67, 8 and 7 is 15. 5 and 6 is 11, plus 1 is 12. 1 and 1 is 2. 225. Next one, 400 minus 163. 0 into 3, no good. We can't grab from that 0, so we'll grab from this one over here. We'll go, that becomes 3. and that can go to this one, and then we can take from that one to make 9, and then this one. 10 take 3 equals 7, 9 take 6 equals 3, and that is now a 3 take 1 equals 2. If in doubt, you can always test out your number. So we want to try to get up to 400, 237 plus 163. 3 plus 7 is 0, plus 1, 3 and 6 is 9, plus 1 is 10, and there's our 10. 1 and 2 is 3, plus 1 is 4, 400. 1.9 plus 0.19, you just need to make sure your decimal places match up. 1.9 plus 0.19. There's assumed to be a 0 here. 0 and 9 is 9. Actually, I'll do it a little bit smaller over here so we can see it a bit clearer. 1.90, 0.19, 0 and 9 is 9. 9 plus 1 is 0. Carry the 1 over. So 9 and 1 is 10, sorry. That's why there's a 0 here and the 1 gets carried over. 1 and 1 is 2. 2.09. This next one, these fractions have different denominators, so when we're trying to minus them, we need to try to get them to be the same denominator. This is a 4, this is a 2. We need to think of it in terms of multiplication or division. We need to multiply this 4 by something to get it to be the same as that 8. Sometimes when you have fractions that you can't just multiply one to equal the other, you just multiply them by themselves. So I'm going to show both methods. So for this one, we can simply do 4 times 2 to get 8. So that's what we're going to do. We're going to do 3 over 4 times 2 equals 6 over 8. And then all we've got is 7 over 8 minus 6 over 8, of course, equals 1 over 8. Now the other way that we could do it, and I'll do it, we'll do it on the back of this piece of paper. I'll just bring that one up a little bit. Hang on a quick second. Okay, so the other way I'd mentioned was multiplying the denominators by themselves. Because for example, if you had, like I said before, I think, let's say if you had 1 over 3 take 1 over 7, you can't multiply the 3 by anything to get it to be sevenths. So then that's when you multiply them by each other. So in this example, 7 over 8 take 3 over 4. Even if I didn't know what I could multiply 4 by, you just multiply them by each other. So this one over here that ends in 8, it multiplies by 4, because that's the number down here. And this one over here, we multiply it all by 8. That's top and bottom. So 7 over 8, if we multiply both numbers by 4, 7 times 4 will be, so I'm going to just put it times 4, 7 times 4 will be 28. 8 times 4 will be 32. Now this one over here, 3/4, we're multiplying both things by 8. 3/4 by 8. 3 times 8 equals 24. 8 times 4 equals 32. So now we can just, now we've got what we call like terms. We've got identical denominator. (28) take 24 equals 4 over 32. And then we can simplify that fraction by just looking at common factors. We know that any number that ends in 2 is divisible by 2. So let's divide them both by 2. So 4 divided by 2 equals 2. 32 divided by 2 equals 16. Again, any number that ends in 2, 4, 8, or 6 can be divided by 2 again. So 2 divided by 2 equals 1. 16 divided by 2 equals 8. And again, we've got the exact same answer. 1/8, 1/8. Onwards to 35. 49 times 3. So you can do this. 49 times 3. 3 times 9 is 27. Put the 2 over there. 3 times 4 is 12. Plus 2 is 14. That's one way of doing it. Another way is like in the earlier question, 3 times 50 minus 3 lots of 1, because 3 times 50 is the same as 3 times 50 minus 3 times 1 is the same as 3 times 49. So again, just to show, 3 times 49, that is going to be exactly the same as 3 times 50 minus 3 times 1. Because do you notice that in this top one, you've got 3 lots of 50. In the bottom one, you've got 3 lots of 1. If you take a 1 from each of those 50s, it's 49. And in both examples, you have 3 lots of them. So that's the same thing that we were looking at in one of the earlier questions. In question, it's on the back here, wasn't it? That was on question 18. Exactly the same principle. 3 lots of 98. So it's just like 3 lots of 100 take 3 lots of 2. 3 lots of 2 is of course 6. Okay, where were we? 204 divided by 6. 204 divided by 6. I'm going to show the two different ways, the simpler way and slightly more advanced. First, 6 into 2, no good. 6 into 20, I know that 3 6s are 18 and that there's 2 remainders. And 6 into 24 is 4. Well, there's no need for the advanced one. Yeah, there's no remainders here, so yeah, 34 is your answer. Again, we can just go backwards to confirm if we ever wanted to. So will 34 times 6 equal 204? 6 times 4 is 24. So 4 down the bottom, 2 up there. 6 times 3 is 18, plus 2 is 20. And there's our 204. 2.4 times 5. 2 times 5 is 10. 0.4 times 5 is 2. 2.0, add them together and that will get you 12. Yeah, the more conventional way of showing it is just like this. 5 times 0.4 will give you 2. So that's a 0 there. Sorry, a 0 there and 2 there. 5 times 2 is 10, which gives you the 1 there. Actually, that's not really the most conventional. Me personally, I would sort of just looking at by doing it in parts. 5 times 0.4 is 2. 5 times 2 is 10. That would be the way I would look at it. But yeah, let me know if that one's a little bit confusing. I can run through a number of examples where it's made a lot clearer. The decimal makes it sound a little bit scarier, but if it was 5 times 24, it's a very similar principle. If you have 24 and you have 5, 5 times 4 is 20. 5 times 2 is 100, and then you just end up adding them together. And it's the same thing, except for we've got a 2.4, which means instead of getting a 20, we're getting a 2.0, and instead of getting a 100, you're getting a 10. So it doesn't actually change the question that much. 9 divided by 3/4 is a little bit more complicated. Yeah, that is definitely a little bit trickier. I guess one way that I would have thought about it would be, how about if we just keep adding 3/4 on top of each other until we get 9 and see what answer we get. So another thing is, if you wanted to know what 9 is in terms of quarters, so if you had 9 cakes equals how many quarters? Well, it has to be 9 times as many pieces to make a whole cake. So if the cake was only cut into halves, we would need 9 lots of 2 halves. Here we need 9 lots of 4/4 if we want 9 4/4 cakes. So 9 times 4 is 36. This now makes the question a lot easier because now I have transformed this into like terms with this. If I go 36 quarters divided by 3 quarters, I can disregard the quarters because they're both the same, and it ends up just being 36 divided by 3. And if you know your times tables, you'll be able to figure it out easy enough. And if not, you can just count up and see how many times. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 9 divided by 3 quarters is 12. Next one, to enter the calculation 6 plus 3 in your calculator, you'd press these keys in order. 6 plus 3 equals. You want to enter the fraction 1/7 in your calculator, right in the order the keys you would press. Well, there should be a fraction button, I guess, on your calculator, but if not, if you just do 1 divided by 7, that will give you an equals. That gives you the decimal of what 1/7 is. So that is a way of getting 1/7. If you've got a fraction button, you can press that. I'll just put fraction. You press that in the middle of pressing 1 and 7. And question 40. Right, in order the keys you could press on your calculator to work out. $3.50, take 35 cents. 35 cents is different to dollars. Cents is our last part over here, $3.50. So again, if we want things in like terms, we need to make sure that we put the decimal in front of the cents, just like there is over here in dollars and cents. So it would actually be 3.50 minus 0.35, which will get you $3.15. But this is our answer here. 3.50 take 0.35 equals. And there we go. That's the end of the test. Let me know if you've got any questions about anything in particular, and I'll be more than happy to help out. Thank you so much for your time.